10.2, example 9. In this example, we're going to refer back to example 8, and we're going to determine the path that the particle takes when it travels from 1, 5 to 9, 21. So recall, we have our velocity vector here, and we want to find the position vector. So to find the path of the particle, we're going to need the position vector. So in order to find our position vector, all we have to do is integrate each of them. So we have that our velocity vector is given by that equation up there. So then our derivative of x is t minus 3 pi cosine pi t. So then I integrate both sides with respect to t. And I get my position vector for x is t squared over 2 minus 3 pi sine pi t divided by pi. And the way I got that pi is I did the reverse chain rule. And then you're going to have to add plus c1 because we need to add the plus c. The reason I'm adding a c1 is because I'm going to have another c value later on for the y. And I know that I'm at the position 1, 5 when t equals 0. So then 1 is equal to 0 squared over 2 minus, these canceled, 3 sine of 0 plus c1. So that cancels, so c1 is equal to 1. Now I'm going to do the same thing with y. So dy dt was equal to 2t minus pi sine pi t. So I integrate both sides. So I have y of t is equal to t squared plus pi cosine pi t divided by pi plus c2. And that c2, the reason I'm putting a 2 is because it's different than the c I used in my previous equation for x. So then because I have the point 1, 5 at t equals 0, I can write 5 is equal to 0 squared plus these pi's canceled, cosine of 0 plus c2. So 5 is equal to 1 plus c2, so c2 is just 4. So my position vector is going to be 1/2 t squared minus 3 sine of pi t plus 1, comma, t squared plus cosine pi t plus 4. And now that all that is left to do is go ahead and graph that on your calculator. So when I trace it out, I can see it doing this little like swirl, and then it goes up, and it looks like it does like a turnaround and just some kind of weird motion. And so this is what the path of the particle goes like, and it'll continue on forever.